Just imagine you have a fantastic job that's paying well, and you've saved enough money to buy a new house. You head over to a real estate agent who shows you 5 houses in a specific locality of your choice. These houses are sized 40, 45, 60 and 70 square meters respectively, and their prices are as mentioned above. But you're keen on buying that one in the middle, which is 65 square meters in size. But he doesn't know the price right off his head and says he will call you, find out and let you know soon. But we can get a close approximate ourselves. In such a case, we can utilize an absolute classic technique called the linear regression. It can help us predict what might be the price of this house considering that the other 4 houses in the same locality are prices mentioned. Linear regression can be of 2 types, single and multilinear. And for the sake of understanding the fundamental concepts, we're going to focus on single linear regression. The word regression means to find a relationship, and when you add the word linear to it, you're trying to find a relationship that is straight in line between 2 quantities. Let's plot these houses on the x and y axis, with the size of the house on the x-axis and the price of the house on the y-axis. The coordinates have been mentioned too. The x values here are known as the independent variables, and the y are known as dependent variables, because it is the size of the house that actually determines the price. And since here we have only one dependent variable, this is called a single linear regression. The aim is to plot an estimation line through these points that best describe the linear relationship between these 2 variables. And a technique within linear regression is called the least squares method. Let's atomize this together and understand what is it that we can achieve with least squares. This line has to pass through the space between these points, but it has to do so in such a manner that it is possible to have the minimum possible error. The error is nothing but the difference between the actual value and the predicted value on this specific estimation line. In least squares, the idea is to minimize the quantity of the difference between the actual and the estimated value, but the square of that. Let's imagine this intuitively. It is actually nothing but the squares that are projected onto this estimation line. Thus, you're actually trying to minimize the sum of the areas of these 4 squares that you see on your screen. So, for example, if the line was moved up there, the overall area seems to increase a little. Or if you were to move it down there, you can visually see a difference in the overall sum of the areas. The movement could be either by moving the line up and down, as we just saw, or by rotating it slightly here and there, or doing both of them. Hence, we need to optimize the position of this estimation line in such a manner that the sum of the areas of these squares is going to be as minimum as possible. Now, this technique has a mathematical backbone to it, which says that for a line that is represented by an equation y is equal to mx plus c, the slope or the tilt of the line is the value m, and the constant c is known as the intercept, which is actually where the line cuts through the y-axis, as you can see on the left-hand side. The following are the individual formulas for m and c, and this scary little symbol that you see is actually called sigma, and it means to sum up, while the value of x here is the size of the house and y the estimated price. To make things easier, I shall take you through a manual process to find out these values, to walk you through how the math is being implemented. And in a separate video, I shall also help you understand that how is it that these formulae are derived, walking you through the calculus. Take note that n here are the number of points on the graph, and in this case, it's 4, because we're using these 4 points to create an estimation line. The steps for linear regression are quite straightforward. We begin with plotting the values of x and y coordinates, and for every point, you calculate the value of x square and x multiplied with y. After which, you find the summation of the values of x, y, x square and x multiplied by y. And then you replace these values in the formula for the slope. After you found the value of the slope, you can then go on to find the intercept. And then you put the jigsaw puzzle together to find an equation for this line. And when you do so, you get something like that. Just to test it out, in case the value of x, which is the size of the house, was say 65 square meters, the price of the house computed would be approximately 74,000 euros. That's what we're trying to find. So now you know, when you type import linear regression, there's a whole lot of mathematics that is going on in the background. Hope you enjoyed this visual grasp over linear regression. And do stay tuned for more, where we break down things into their most indivisible form, atom by atom.